Good morning, everyone. Today's distinguished speaker is Dr. Werner Geyer, Chief Scientist, Human-Centered AI, Principal Research Scientist at IBM Research. Today's talk is titled Human-Centered AI, Creating Trustworthy and Effective User Experience with Generative AI. Dr. Geyer is a Chief Scientist at IBM Research. He co-leads the research agenda and strategy for AI interaction technologies and Human-Centered Trustworthy AI. An ACM Distinguished Member, Dr. Geyer is renowned for his pioneering work in computer-supported collaborative work, AI-assisted collaboration, and enterprise social software. In his leadership at IBM Research, Dr. Geyer has successfully transferred innovations into products by collaborating across divisions and managing long-term joint research programs with various IBM business units. His scientific expertise is recognized globally and frequently contributes to conference and workshop organizing committees, program committees, and serves as a conference chair or a reviewer. Dr. Geyer's research has been widely published in top avenues such as SHI, CSCW, IUI, and DIS. He has co-authored over 100 publications and holds more than 40 patents. His contributions have earned him multiple Best Paper awards and internal recognitions at IBM for outstanding technical and scientific achievements. He is a co-founding editor of the Human-Centered AI publication on Medium. Dr. Werner, it's quite a mouthful of achievements, and thank you so much for being here this morning at University of North Dakota. It's a great, extreme honor to have you, and the floor is yours. Thank you again. Let's see if you can share your screen.
All right. Thank you very much for the introduction, and thank you for having me here today. Now, let me just go back to the screen sharing. Desktop 2, share sound, share, and let me see. Okay, so you should see this now. Cool.
Yeah.
All right, then let me dive right into this. So my talk today is about our research agenda at IBM Research around human-centered AI, and more specifically, with the rise of generative AI, I want to focus on how we have actually refocused our human-centered AI research on two aspects of generative AI. The first one is how to make experience trustworthy, and the second one is how to make them effective. I will be arguing today that designing the interaction between humans and AI systems is critical for their success in practice. And that success is not always granted. It's actually not easy to get it right. And we can have the best algorithms, but eventually they will fail if we don't make them accessible to human users in a way that empower them to do their work better. So before I dive further into this, I hear this a lot. So I'd like to clarify this right in the beginning. Human-centered AI does not equal HCI. So human-centered AI touches upon every aspect of how humans experience AI. So our research combines approaches from data visualization, HCI, CSCW, design, social sciences, interactive AI, and more. So it's a very multidisciplinary discipline. And speaking of that, I thought I should also start with offering you a definition. I'm not sure if everyone is familiar with what human-centered AI is, and you will, if you look up online, you will find other variants of this definition. So there's not a single agreed upon, although there is a lot of overlapping aspects. And we also wrote a blog post about human-centered AI and IBM Research perspective on it. There is a URL on this slide. So if you're curious after this talk, so please go ahead and read this article. So human-centered AI for us is an emerging discipline intent on creating AI systems that amplify and augment rather than displace human abilities. Human-centered AI seeks to preserve human control in a way that ensures artificial intelligence meets our needs and achieves the benefits of automation while also operating transparently, delivering equitable outcomes, and respecting privacy. So this is a lot of words, and I wanted to take also a few minutes here in the beginning to examine some aspects of this definition a little bit further. Speaking about the first aspect here, emerging discipline, you may or may not be aware that Stanford has been playing a key role in establishing this term through its Institute for Human-Centered AI. We actually do also have a collaboration with them. There's Ben Schneiderman's book that came out 2 years ago on Human-Centered AI. There's other books by Elsevier that also came out more recently. But probably the most significant sign here that this is a discipline is that some schools in Europe, they now offer master's degree in human-centered AI, for example, HCAIM in Budapest and Utrecht, Naples, Dublin, the Technical University of Denmark, the University of Göteborg in Sweden, and then there's also a few schools in Italy, in Milan and Pavia, that actually do offer a degree in human-centered AI. And also very proud to say that our own team brought 2 workshops on human-centered AI to NeurIPS in 2021 and 2022, jointly with Ben Schneiderman. So the second aspect I want to talk about is augmentation. And you are probably all very familiar with the term human in the loop, which has been very popular in the early days of the AI renaissance. I use that term too, because I have gotten used so much to it, but I have never been actually a really big fan of this term, because it kind of suggests that there is a loop full of AI systems and a single human, right? And it also suggests it's all about automation and removing as many humans as possible. I just personally think that augmenting human capabilities is a much more optimistic and also realistic perspective on how humans and AI work together in the future. It essentially puts the human back into the center, and it's about empowering humans. And this is a perspective that's very much in line with Tom Malone and also Ben Schneiderman's thinking. You can see here this quote from Tom Malone that I have on the slide suggests that our guidance should be rather to think about how to design and build AI systems that work together with humans versus replacing them in order to achieve these superior outcomes or results, right? And I'll talk more about that later because that's really an important topic. So the perspective here is AI as a tool to give humans superpowers, and human-centered AI is about putting people first. So the next aspect of this definition is human control, and this is actually one of the tenets of human-centered AI. It is preserving human control. You will find this in many, many definitions of human-centered AI. But if you think about automation, designing for automation is a really challenging problem. If you take away too much human control, although it may be well intended to make things safer, it sometimes can be fatal, in particular in high stakes use cases, like in the healthcare domain or in aviation. And I put 2 examples here of the recent 737 MAX crashes. As you probably all remember, right, there was an automated system that forced the planes into a steep dive after takeoff. It was an anti-stall system, and there was a faulty sensor, but the whole system had really bad product design, right? There was a warning light, but that was part of an optional package that some airlines didn't even buy. Manual override was not only difficult, but some of the pilots were not even trained. Interestingly, this also illustrates 2 challenging problems in the existing airplane technology that are also meaningful in the context of AI. So these are automation transparency and automation complacency. So with automation transparency, very similar to explainability in AI, right? Airlines and manufacturers, they struggle to properly educate pilots on the latest automated systems. And this problem gets worse as the technology gets more advanced. But then when the pilots eventually catch up, they're found to overuse the automated systems, which leads to complacency and the degradation of the manual flying skills. So I think the lessons learned here are very relevant to the world of AI today and how we build AI systems. And complacency or over-reliance is an interesting area that's actually really hard to study, as it often requires longitudinal research. So this is an area where I would love to do more research, but I haven't done much in that space. So the next aspect is meeting our needs and benefits. So as you all know, AI has been hyped a great deal, even more so with ChatGPT since December 2022. So expectations are high, but we also need to be reasonable, right? AI isn't necessarily the solution to every problem, right? Although we have the tendency to apply it to many problems these days. If we're going back a little bit in the past, probably a good example is the very early hype about chatbots, not the chatbots that were driven by LLMs, but the earlier versions. I just remember this vividly, that they were considered a remedy to almost every problem, but either the problems back then were too hard to solve with a chatbot and they fell short of expectations, or the problems were too simple so that the chatbot even didn't even make sense, right? For example, in many cases, chatbots became glorified Q&A systems, for which we wouldn't really need AI. A simple search of a Q&A page, maybe that's an extreme position here, they would do the job, right? So in this context, more importantly, I also wanted to share an interesting analysis that Tom Malone and colleagues have done earlier. I think it was about 2 years ago, looking more systematically into automation benefits through AI. They did propose a new metric to measure human plus AI performance. So if you put them both together, you would hope that the performance is higher than each one separately, right? But what was really eye-opening about the study is when they looked into 79 experimental results, they were all from 2021, I think, evaluating performance improvements. Slightly more than half of these results, they demonstrated a decline in performance. And the maximum performance gain was 36% that they could observe in this existing research. They also conducted their own experiments, I think with about 100 programmers using GPT-3 for a programming task, and they could sort of confirm the results of their survey, right? Because they also found only a maximum of 27% performance improvements. So you can see, even if an AI system may meet our needs, creating these beneficial outcomes isn't always easy, and the systems often fail to reach their promise. Okay, last aspect of this definition. So as we give superpowers to humans through AI, we also want to make sure these systems are operating transparently, they provide equitable outcomes, and they respect our privacy. You have probably heard all the many goals that people associated with and propose for AI systems. On the top left, you see a screenshot from Ben Schneiderman's book that shows you a good collection of those: reliable, safe, explainable, auditable, etc. For us here at IBM, many fall under the umbrella of what we call trustworthy AI. I particularly picked actually those three here because I think they're exacerbated through deep learning models, in particular large language models, right? Most of these models are black box models, so transparency is really hard to achieve, but it's very important. They're fed with so much data, a lot of the data is biased, so equitable outcomes is really important, and then the same holds true for privacy, right? Because as you have heard probably in the popular press, there have been also many privacy leaks in LLMs. Given all the data we feed in there, it's really hard to avoid that something like this happens. So if you want to dig a little bit deeper, I left you 3 book recommendations here. There's Kush Varshney's Trustworthy AI, Michael Muller's Human-Centered Data Science, and then of course Ben Schneiderman's book on Human-Centered AI. All right, so segueing into another part of my talk. So if you think about human-centered AI, right, as an emerging discipline, it has been actually around for a while. But the rise of foundation models, such as large language models, has introduced a new AI paradigm. We have known this for a while. The Nielsen Group even calls this the first new UI paradigm in 60 years. But computing interfaces, they have evolved from batch processing to command-based interaction to what Nielsen now calls intent-based outcome specification. You know, right, in command-based interaction, which is still the dominant paradigm today, right, users tell the system how to arrive at an outcome through a series of actions, right? With intent-based systems, we actually have a shift of the locus of control over more to the computing system, and we tell the system what we want as an outcome and not how we arrive there. So understanding how to design interactions with intent-based system is new, but it's really important so we can best support users in getting the outcomes that they want. So, and with the background, right, given this paradigm shift and also the new risks and harms introduced by generative AI, we decided to refocus our own research efforts in human-centered AI on a simple mission, creating trustworthy and effective user experience. So this is also the subtitle of my talk today. And the research we do can then also accordingly roughly categorized in either of those two work streams: trustworthy and safe generative AI and effective interactions with generative AI. So I have selected about 1 or 2 projects for each of these areas, given the limited time we have today, although it is actually a generous time, but I have a lot of content. And also these projects, it's not just as a heads up, right? These are all team efforts, right? Behind each of these projects, there's a larger team. This is not all work I have done by myself. So I have to give the credits to all these wonderful researchers who have worked with us on the Human-Centered AI team to do this kind of research over the years. So let me start with effective interactions. And what I mean by that is, as I mentioned earlier, is augmenting human abilities. It's all about human plus AI, is bigger than each one separately. And let me kick off this segment here by showing you the last 2 minutes of a video. This is actually a 5-minute video. It's from a recent award winner at the Runway AI Film Festival. It's from last year. And you should be able to hear the audio. So let me just play this.
AI developers didn't stop there. They kept scraping the internet to make bigger data sets, to train bigger models on more powerful computers, until those models could be prompted to offer ideas of their own. They can write poems and melodies and code, make images of anything you can think of in any style you can think of. They're moving to video and 3D and VR. It's an incredible pace of change that can leave you wondering, where does human creativity fit in all this? That's a question that painters might have asked in the 1830s, when the rare and exacting skill of creating realistic images was abruptly automated by photography. The new medium was not immediately accepted as an art form by painters, but they soon began to find reference photos quite helpful. And the next generation redefined the goal of painting altogether, sparking the whirlwind of innovation that we call modern art. It's been said that every abundance creates a new scarcity, and when you sit in front of a generative model that's asking for nothing but good ideas, it's your own creativity that feels scarce. Each dot on this map is an image that's been generated with stable diffusion, and they cluster in these congested regions: robots, celebrities, animals. So many back roads for unique thinkers to travel. Getting there, though, requires some skill. What seems like a heavily automated process can in fact be directed in many ways. Whether you begin with the seed of an idea or a fully formed plan, a growing number of settings and tools let you claim more creative ownership of what happens next. And by retraining large models on more curated data, it's already possible to collect as many personalized playgrounds as you have time to think up. The output from a generative model isn't the end of the process. In skilled hands, it's just the beginning. For the first time, we have a technology with the attributes of a good collaborator, one that offers useful but unexpected ideas, that takes feedback and tries again. Gone are the days when we faced the blank page alone. And in exchange, you and your audience will never really know where you end and the machine begins. I won't lie and say that I know where this is going, but we know that there's no going back.
Okay, so let me stop this here. I hope this video made a couple of points in much more powerful ways than I could have ever done this in my own words. What really stood out there for me is the analogy between painting and photography. That was a really good one, as it highlights that human skills are always needed, but that there is often a shift in skills. More importantly, for my own case, what the video also made clear is that for the first time, it feels like AI is a real collaborator, a good collaborator. And we have used this term human-AI collaboration for so many years, but in reality, much of the research that was done was showcasing this only as a unidirectional communication. So, but as the video said, gone are the days when we face the blank page alone. So, and this notion of human AI collaboration in the area of, you may have heard of this domain, computational creativity, it's also often referred to as co-creation or co-creativity, that is humans and AI systems working together to create physical and virtual artifacts. And generative AI for the first time is making this a true possibility. And we focused on, in particular, on this co-creation aspect. And now I'm zooming a little bit back in time here. So we focused on this co-creation aspects for a while. We started exploring business opportunities for generative AI already in 2018. So it's about 6 years ago. And if you think back then, right, there were already many encouraging examples that should have alerted us way before ChatGPT came on the market. Like Airbus designed a new compartment divider for the A320 that used less material, increased maximum load capacity, reducing CO2 emissions. Airbnb developed a sketch-based user interface design tool that empowered designers to test UX designs faster by translating sketches into code. Autodesk has been working in the generative space for a very long time, even before deep generative models were available. And here at IBM Research, already back then, we demonstrated a path for the discovery of antimicrobial peptides. Not sure if you know those. This is for the crisis of antibiotic resistance, right? We showed we could discover those, reducing drug discovery times from 2 to 4 years to 48 days. With about 10 times higher success rates. So back then, it already became clear that with sufficient effort, although it was hard to do that, right, but we could produce really good results. So we could argue that we reached some level of fluency, which is a term that Douglas Ack used in a workshop that we ran in 2020. So while we had this kind of fluency already back then, one key question that really emerged for us is how do you design these interactions between a subject matter expert and a generative AI system to achieve superior outcomes? And this is not a trivial task, right? You remember Tom Malone's work that I presented earlier. If you think how the roles of humans and AI system changes with generative AI, right? With intent-based outcome specification now as an interaction paradigm, the role of the human changes towards specification, steering, goal setting, higher level creativity, whereas the AI can provide inspiration, lower level creativity, do detail work, generate variations that improve quality or speed. And yeah, just remember the empty prompt at the video earlier, but how do you tell that system, right? The production process of these models has become much, much better by today, right? But it is still often hard to get the desired outcome. Algorithms often lack an understanding of the actual intent, right? And many of them are feed-forward. And given that the locus of control has shifted somewhat over to the AI system, it makes it much, much harder to allow for control and steering output into the desired direction based on the human input. Then you have a problem that these algorithms may produce too many candidates, making it difficult to choose from. So there's information overload that can occur. And we may also have to address motivation of subject matter experts to use these systems because they might experience or feel a loss of ownership. So I wanted to give you one example of a very early tool that we developed. So this is GanPaint. This is a co-creative painting tool. Of course, you find much fancier features today in Adobe tooling, right? But this was one of the first tools, actually. We developed this together with MIT. This was one of the first tools that allows editing with generative networks. And it's a pretty cool painting tool because you don't paint by manipulating pixels, but rather at the semantic level with neurons by manipulating the latent space. So what you can do here is in the UI, you can select objects such as trees, doors, bricks, etc., and you can just decide where you want to put them. This is actually a good example for intent-based outcome specification, right? Because you tell the system that you want a door there, right? Or a window, right? For example, I've added these two trees here on the right-hand side to the cathedral, to the left and the right, right? And if I added doors to the building, the model would exactly know the right proportions, merge them nicely into the existing image, because the model has learned the properties of these objects. And that also relates back to when I talked about the locus of control is shifting, because many of these activities are now done by the model and not by the human. Now, another interesting aspect to highlight here, if I try to add a door to the sky, the model would not allow me to do that, because it has learned that doors typically cannot be found in skies. And this is a good example of how this kind of interaction with a generative model is not only human-directed, it has aspects of system direction, which is yet another good example of how the locus of control is shifting towards AI. So it doesn't do what it wants, and it shows, you know, that there's a problem with the lack of control, right, at some point. And it makes you also then reflect about creativity. But this is a discussion I do not want to go into. So I left you a URL here. We still have a version of this tool up and running, so you can play with this yourself. So beyond, this was just one example. We had few initial explorations of this domain, but we eventually started looking into more IBM business-related domains, applying generative models to the software engineering domain. So the SME is a software engineer, and we do AI for code and superior outcomes here, improving speed and quality potentially. And software engineering domain, right, this includes coding, documentation, testing, right? These are the various tasks that we could support. And we wanted to understand more systematically if and how we can achieve these superior outcomes with existing models. So let me share a few results with you that we have developed over the years. So in our first experiment, we wanted to understand if imperfect code models still can be useful aids to software engineers. And back then, the state of the art was about 70% accuracy. So this is much, much higher today, right? But things are still not perfect, of course. So in one experiment, we explored the user experience of assisting software engineers with code translation from Java to Python. And the envisioned use case here is, I don't know if you've heard about this, is application modernization. It's a time-consuming and tedious task, but it's also, of course, a multi-billion-dollar industry. So to find out, we conducted a design probe, that's how we call this, with 11 participants through semi-structured interviews. And we really wanted to understand first, attitudes towards automated code generation, and second, also get some feedback on the user experiences we designed. So for example, here on the right-hand side, user experience A shows the transcoder translation plus confidence highlighting, where the model was less confident in the translation. User experience B shows the transcoder translation and alternate translations. And then aside from this, what we usually do, like getting detailed feedback on the user experience, right? There's a few interesting findings that came out of the interviews that I'd like to highlight. So we did observe high tolerance towards mistakes made by the model as long as the generated code saved people time. They expressed willingness to review and improve upon the code. Trust came up as an issue, but however, in contrast to many, many other systems, the participants here in this use case, they were not really interested in understanding how the model functioned under the hood, but they argued that trust should be established in a very similar fashion as if the AI were a team member, by verifying the work through code reviews. And along the same lines, right, similar to human peer, people felt compelled to give feedback during code review, and they would expect the system to learn based on their feedbacks. It's sort of like teaching a junior software engineer. I left you also a reference to the paper that was published here. I think this is an IUI paper if you're interested in some deeper results on this. But the journey goes on. So of course, we also wanted to understand whether these imperfect code models also provide quantifiable benefits, right? And remember, as I mentioned a couple of times earlier, these benefits are not always for granted, right? There's Tom Malone's chart I showed you earlier with about only 50% of the experiment showing performance improvements. Of course, we looked into existing literature and what others had done, and findings have been mostly inconclusive, I would say. There's the paper by Zhu et al. Here on the top right in my chart. There's also an independent paper evaluating Microsoft Copilot that did not necessarily improve task completion time. So people there face difficulties understanding, editing, debugging code snippets generated by Copilot, which hindered their task solving effectiveness. So mostly inconclusive. So what could we measure? So we wanted to do our own experiments, right? Quantifiable metrics could be related to the artifact being created. So in this case, code quality. They could be process-centric, so we can measure speed, how fast software developers complete a task. Or they could be related to overall experience. So for example, user satisfaction, joy, engagement, etc. So of course, while we were building and studying our own AI-assisted coding support system, right, GitHub Copilot came out, I think it was about 2 years ago. And there was also a user study, but this wasn't an independent user study. So in that study, they demonstrated a 55% speed improvement as well as improved developer satisfaction along a few dimensions, right? So you see the results are sometimes contradicting if you see the independent paper versus the dependent research. But the devil there is often in the details with these studies. In our own studies, here's what we found. We focused mainly on code quality. So we asked 32 software engineers to translate 2 data structures from Java to Python in a within subjects experiment, and the goal was to produce a correct and complete translation with and without AI assistance, right? And in this work, this is the the paper on the top right here. We did observe a significant increase in the quality of the code generated, with a 50% reduction in error rate and a 20% increase in the proportion of correctly translated methods. And then we did another related study with data scientists where we leveraged graph neural networks to auto-generate documentation. And we also observed a small increase in speed, with data scientists needing 21% less time in writing documentation at the same level of quality. What's actually more remarkable to me about that study on the bottom right is that 80%, I think, of the users, they accepted the recommended documentation, which kind of speaks to these kind of superpowers, right? Because if you think about it, otherwise this documentation probably would have never been written to begin with, because people are notoriously bad at that. Where's the but, right? So here's the but. So an interesting observation here is that while there was a significant overall increase in quality, not everyone actually benefited from the AI assistance. So if you look at the individual participants and not at the overall results, we found that actually only 53% of the participants actually saw these benefits. And well, you might say, well, didn't you check for skills or so? Yes, we did control for skills before the experiment. But still, people overestimated their skills, right? This is often also referred to as the Dunning-Kruger effect. And those people who did not benefit, they spent a lot of time trying to understand the auto-generated code, right? Before they even could start improving it or fixing it, right? And we did have a one-button integration, so the control wasn't really very fine-grained, right? So you press the button, you get the translation, right? But people may also need different types of support, right? That are a little bit fun and support them in their needs. For example, in this case, you can think about line-by-line translation and so on, right? Let me summarize this segment and what we have learned from these initial studies, right? So models, they don't need to be perfect to be useful, so that they can be used if they're used correctly. Also, superior outcomes are possible, right? They can be measured, but generally speaking, you don't get these outcomes for everyone, right? And I think the takeaway is the big question here for all of us is, how can we help more people be more effective with these technologies, right? And then designing the interaction in a way that makes these benefits accessible to different groups of people who come in with different background and skills is really critical. We also found in other user studies that our users, software engineers, they like to have more control over the code being generated. So there's topics that came up like controlling runtime performance, memory footprint, readability, modularity, maintainability, and so on. So control is important. Now, if you think about it, with all these initial code translation experiments, I talked a lot about human AI collaboration in the beginning. But there wasn't really much collaboration, right, in these either, right? It was more unidirectional. So we did aspire in this large project to explore more multi-turn interactions with back and forth between software developers and the AI system. And we decided to build a chatbot conversational experience called the Programmer's Assistant. There was a lot of skepticism on the team, including myself. But let me just show you this video, and then you can get a sense for what the team has been building then. It's
development process.
Oh, I need to rewind that.
The Programmer's Assistant is a research prototype intended to explore the utility of a conversational style of interaction in a coding environment. The assistant will not monitor the programmer's activity nor give unsolicited advice. It provides a chat tool that sits quietly off to the side or completely hidden until it is called upon. It is based on the Codex large language model, which has been trained on 159 gigabytes of Python code from 54 million GitHub repositories. It can communicate in natural language and generate code. Here are a few of the things that the Programmer's Assistant can do. It can answer simple questions to streamline the development process. It can conduct a dialogue about the answers it has given previously. Inline responses can be instantly copied to the clipboard to be transferred to the work in progress. The assistant can generate more complex code as well, even whole functions. When a larger code sample is generated, it opens in a preview window and is represented in the chat by an icon. The preview window provides an easy way to copy code to the clipboard. The assistant can provide explanations for the code it has generated. It can also produce alternative implementations. It can even compare and contrast the alternatives, discuss concerns, and educate the user on programming topics. The Programmer's Assistant is given access to code that is selected in the program editor when the user creates an entry in the chat. The user can engage the assistant in discussion about the selected code or ask for explanations, documentation, or test suggestions. The Programmer's Assistant retains a memory of the most recent interactions in a session. Sometimes this can cause it to fixate on a past answer, and is helpful to clear the memory by asking it to start over. This will cause it to forget about earlier interactions. While the assistant contains a great deal of programming knowledge, it is not perfect, and sometimes it will misunderstand questions or give incorrect or misleading answers, so all information it provides should be considered with skepticism. If an answer seems odd or incorrect, it's worth asking it to try again to see if it can generate a different and hopefully better. The Programmer's Assistant is a research prototype intended to...
So let me stop this here. I think you have seen enough. And maybe since December last year, this may not seem so exciting to you anymore, but note that we have done this work about a year before ChatGPT came out. And so this was based on Codex, and chat was simulated with Codex with proper prompting. Now, of course, we did study this, right? And with 42 software developers, we asked them to do real-world programming tasks with this. And as you can imagine, right, there was a lot of skepticism to begin with because chatbots were still stuck in the olden days back then. But then after they went through the study in the post-task survey, right, their reactions exceeded our wildest expectations. So everyone wanted to have this tool. But I just wanted to mention this. If you're also interested in other aspects of this user study, the design implications and how to build conversational coding assistants, there's much more in the IUI paper that I've listed here on the bottom. So there's a lot of rich content for you to draw from. So I wanted to talk a little bit instead of showing you more studies, right? I've shown you a few of those, right? You may ask here, what's the guidance, right? How can we create successful experience? And while some of the work we do has more immediate product impact, right? Some of it leads, on the other hand, to deeper understanding and knowledge how to build effective human AI experiences. And based on the knowledge we gained from the research we've been doing over the years in this domain and deep literature research, we have created design guidelines for foundation models for our internal design teams. There was really an urgent need for this kind of guidance on how to design user experience that foster effective and safe use. And at the core of these internal guidelines are 6 design principles. So 3 of these principles, the ones in blue, they should be familiar because we've seen them come up before in the design of AI systems. These are things that we already know are important, but what's different here is that we have new interpretations of them when viewed through the lens of generative AI. Then the other 3 principles in yellow, they're completely new, and they identify some of the unique characteristics of generative AI. And in each one of these principles in our guide is coupled with a set of specific design strategies that design practitioners can use to implement these principles within their user experience. For example, if we look at generative variability, right, it's one of the most important concepts. Each time a user works with a foundation model, the output of that model will vary. So even if a user provides the same input to the model, for example, a prompt, the model may produce different results. And generative variability makes it difficult for users to achieve replicable results, right? And that, of course, violates common characteristics of fundamental UX design, right? The rule of consistency that every time you interact with a computing interface, you provide an input, the same input, you should get a predictable and consistent result. So the question is, how do you design for that, right? And then some of our strategies in this box include the selection of multiple outputs, supporting this, showing all versus best, but then you need to decide about strategies, what is best, visualizing the user journey, the history of what they created. You can see some of these aspects in DALL-E, including prompts that created this output, right? Then the capability to manage output through collections to allow them to annotate, organize, and label and search those collections. And then for similar outputs to show the difference between these outputs. So these are some of the strategies that you will find in this design guide and the design principles. And this is the Kai paper that was recently published. I also left you some links. There's a Medium article and the Kai paper about this. The first principle is actually design responsibly, and this is something we should be mindful of when designing any product with or without AI. So this principle is all about ensuring that our products minimize harms to our users. And given the new risks posed by generative AI, designing responsibly is more important than ever now. The design guidelines we developed, they also gave rise to a taxonomy of the different kinds of risks and harms that may be posed by foundation models. So I've put a URL here. I highly encourage you, this is publicly available. I highly encourage you to take a look because this is a pretty comprehensive taxonomy. It's grouped into input risks, output risks, technical risks, and it goes much deeper than I have time to talk about today. And this is constantly updated, so future versions will also include mitigation strategies and approaches to tackle these risks. And of course, as you can imagine, right, we have many initiatives underway in research to detect and mitigate those risks. So this also brings me actually to the last portion of my talk today. Right, it's immediately relevant to our research area of trustworthy and safe AI. And I wanted to give you a glimpse of some of the work that we've been doing in this space, right? Give you a little bit of background, right? AI is being used in many high-stakes decision-making problems, such as loan approval, credit assessment, offering jobs in recruitment, admission into universities, government areas like criminal justice. Given these high stakes, regulations have been put in place, right? There's the EU Artificial Intelligence Act that requires transparency, governance, auditing, and explainability as important elements. In the US, we have the Bill of Rights, the AI Bill of Rights, but not yet legally binding. So trustworthy AI is a big topic with many facets, right? But one of the bigger challenges in this context is actually creating fair and unbiased models. And why is that? Of course, right? There's for once, there's all the bad data that goes into the models that reflects human bias in past decisions being made. But in addition to detecting and mitigating bias, there is also the challenge that people often do not agree what is fair versus unfair, as this may in part rely on their personal experiences. And you're probably well aware with many of the high visibility cases of machine learning bias in the news from the past few years, ranging from racial bias in healthcare, gender bias in recruiting systems, unfair treatment of college qualifying grades for students from a poorer background in the UK. So this is a real risk when deploying AI systems, as much harm can be done. There is, consequentially, right, there is a large body of research on mitigating bias, and there are various toolkits out there to cope with bias, including IBM Fairness 360, Google Fairness Indicators, TensorFlow Constraint Optimization, and Microsoft FairLearn, and many others. And generally, algorithmic fairness approaches, they fall into group fairness and individual fairness. And in group fairness, we require equitable treatment of groups of people, for example, comparable loan approval rates for men and women. And the idea behind individual fairness is to achieve similar treatment for similar individuals. For example, two job candidates that are different only in gender or name, they should receive similar treatment. Now, if you think about it, data scientists and machine learning practitioners that create these models, they play a critical role in making decisions about which model to use to achieve fairness. So we were really curious. We ran an experiment here with 24 machine learning practitioners because we wanted to understand how they go about making decisions when presented with different views and metrics about the models they have to choose between. So we gave them the task of selecting a classifier that catches and flags any text that might be toxic, making them assume a fictitious social media platform where people can post announcements to colleagues and friends. And for each of the tasks, they had to choose one out of three classifiers. Right? So in the first view, we showed them simple performance metrics, including toxic accuracy, non-toxic accuracy, false positives, and negatives. For each of the three models, A, B, and C. And you can see here that over-predicting for this task was very important to people. The majority chose model A because model B and C, they missed out on some of the toxic comments, and A had the highest toxic accuracy with 86.8%. Then in the second view, we showed group fairness metrics for various identity groups. The screenshot here shows toxic and non-toxic accuracy for an African, African-American, and a Black subgroup. The majority chose model C, 50%, because those folks understood that the model was more balanced compared to A and B in terms of toxic versus non-toxic accuracy. And the last view included individual fairness metrics, showing how individual statements were classified as toxic versus non-toxic by these three models. The majority chose model B because it was most stable to changes of identity words, as the toxicity shouldn't really change, right, if an identity word is altered. So let me disclose to you what these models actually are here on the right-hand side. So model A was a standard BERT model with balanced accuracy. Model C was a group fair model, and model B was an individual fair model trained with an IBM fairness library. So if you look at this, right, at the first glance, you could say, well, this is great, right? The view designs and the selections that were made by our participants are actually aligned with the training objectives of these models, right? However, you can also see that there's still a lot of people who chose the wrong model, right? In particular for view 2, it was a very close call with 42% choosing model A. And this choice is a reflection of many people being fixated on toxic accuracy and them not understanding or realizing the consequences of low non-toxic accuracy with many false positives for a minority group. In this case, non-toxic accuracy was actually 59% here, right, in that section number 2 here. And I think this is a good example that shows how easily things can go wrong, and that the user experience needs to be carefully designed and carefully convey information to avert these consequences to the extent possible, right? So in our experiment here, there was a lot of polarization generally around over versus under predicting toxicity. So people didn't really understand the consequences of those. And the most important lesson to take away from this small experiment is what is shown, and how are things shown is incredibly important to make algorithmic progress succeed in practice. For example, deciding what algorithms to choose to mitigate bias. Another finding here that I don't have a slide for, but it was really interesting, is that we learned that people were often guided by their own personal experiences when it came to evaluating model fairness. And given this diversity of our personal experience, it is really vitally important to involve a diverse team and diverse stakeholders in the machine learning lifecycle when it comes to making fairness evaluations in practice, and maybe evaluating harms and risks in general, right? But in this case, this just came also directly out of this study. Okay, so my last topic. I'll try to wrap this up in 5 minutes. So one of the, you may be interested in this one too. So one of the most well-known risks with large language models are hallucinations, right? And bad things have happened here, right? Such as that New York lawyer that submitted a brief citing 6 non-existent judicial decisions produced by ChatGPT. Air Canada had this chatbot that hallucinated answers inconsistent with airline policies, right? And companies leveraging large language models, they really want to avoid these incidents at any cost, right? They cost money and reputation. So detecting and mitigating hallucinations is a very active research area for us. We also offer various tools in our product suite to deal with hallucinations. And here at IBM, we're mostly interested in RAG use cases, so retrieval augmented generation, as this is a typical customer scenario where customer bring their own data and we create a Q&A system based on that data and a large language model. And in this context, we define hallucinations as the generated content is nonsensical or unfaithful to the source. Sometimes we call this faithfulness or factuality in our research, and then accordingly, right, we can compute faithfulness and factuality scores here. So how can you address hallucinations in these use cases, right? There are 2 approaches, so very tightly coupled. We can compute faithfulness scores for parts of the content, predicting the likelihood that the output was generated based on the RAG context or the source provided. And on the other hand, we can also compute source attributions with score coupled with scores that basically point back to the source document at various levels of granularity. And they're very tightly coupled, but you can also use different algorithms for these. So SHAP is an algorithm that we have used here, but there's many other approaches. If you're interested in more algorithmic approaches, there's a URL pointing to one of our preprints here on the bottom, right, where you can read up more about algorithms for these use cases. But from a human-centered AI perspective, right, the question here for us, how do we leverage these great algorithms and the scores most effectively? How do we best communicate these scores, right? So very quickly, we ran a study with different response designs that leverage factuality scores in a Q&A use case in different ways. So there is an unannotated baseline, right, of an LLM output. You can see this here on the bottom, right? And then we use different shadings that reflect the certainty. So we're showing these scores and then at different levels, right? For example, second to bottom, highlight threshold is highlighting only when a certain threshold of uncertainty is reached, right? Or you could show the scores, right, in the output, or you could just always highlight the certainty scores. And then you can do this at the phrase level, you can do this at the word level and the term level, right? So we had a bunch of conditions, about 100 participants in this study. We measured how easy it is for participants to validate accuracy, how it helps users increase trust, and what are their visual preferences. So I did leave you another citation here at the bottom if you're interested in all the results. Today, I only wanted to show you one result from that body of research that illustrates how important UX design can become in order to make algorithms used in our applications most effectively. So we categorized our participants into 2 groups. Those participants who rated the baseline response accuracy at or below 4. right? So low. And the high baseline accuracy group who rated the baseline response accuracy as 5 or higher, right? So participants in the low baseline accuracy group, right? You can see this on the right-hand side here, black bar. They initially rated the baseline with low trust that reflects under-reliance, right? But subsequently, they increased their trust rating after they've seen our annotations and our highlights and after reviewing the factuality scores. Now, in contrast, on the right-hand side, participants that actually were over-trusting, so the high baseline accuracy group, they initially had higher trust, the large black bar here, in the model's response, but subsequently they decreased their trust ratings after examining the factuality information presented in each of the design styles. So what this shows is that this user experience has helped calibrate trust, right, between the different groups of people. What it means in practice, right, is that over-reliers become a bit more suspicious about the response and will more likely validate responses more often. Under-reliers can trust more and will spend less time unnecessarily validating responses. All right, so now I need to really stop here because I have only 5 minutes left. Since you have access to this, I left you a few links here to some of the open source toolkit that we have available in the space. Also wanted to point you to a Human-Centered AI Medium publication if you're interested in publishing there. It's sort of in between writing short messages on Twitter and writing long articles in publications. So if this topic interests you, feel free to contact us. And let me just wrap it up with these 3 messages here, and then I'll open it up for a few questions. So a few takeaways here. So I hope you learned today that designing the interaction between humans and AI systems with human-centered approaches is really critical for their success, and that success isn't just given, right? I've tried to illustrate this today. So, you know, you always need UX plus AI, right? You may work with designers today or have a design department, but the risk is still that one designs for the technology after the fact versus the other way around, to design for the users. And then the last message I want to leave you with, it's really important to involve diverse stakeholders. This was most prominently expressed in the fairness research I showed to you, but it's always true when it comes to making computing systems successful, as they are socio-technical systems. And with this, thank you very much. Did a lot of talking, and yeah, I'm available for any questions that you may have in the last, 3 minutes. I want you.
The more the merrier. So thank you so much.
The more the merrier. Okay.
Dr. Werner, for your time. And I think it's very interesting to, see all these different work summarizing this, It's interesting that you say that, the definition is amplify and augment, or not necessarily displacing human abilities. There are so much variations of these definitions of HCI that we see on literature. But anyway, we'll open up some Q&A thing to see who has questions, and then we can attack them. Maybe, let's see. You maybe I'll start with the first question. When you talked about some new characteristics, this co-creation, right? You mentioned about one of them is a co-creation, and there are a couple of other things I also saw. Generative variability and design for imperfection, right? Do you see any kind of ranking among these 3 things, in terms of which is more important, or I mean, is this something that your group came up with, or is this something that you guys, I do see that, yes, it's correct that these outputs, they produce different outputs for each time. They're not consistent. We get that, but do you see any ranking between the current interpretations on the design versus the new characteristics that you talk about?
So I think the question is targeting this chart here. Is there any of these 3 characteristics, design for co-creation, design for imperfection, and design for generative variability, has any ranking? We did come up with these, yes. So that was an easy answer for that part. And the ranking, which one is more important than the other one? It's really hard. We haven't really thought about the ranking. In my personal opinion, right, generative variability is the most important one. That's also why I mentioned it. But it's really hard for me to put this in numbers, right, or rank this. These are just characteristics that come mostly with these intent-based outcome specification systems, right? And we need to deal with those in the design, right?
Great. Let me read these questions. Can you comment on how group fairness can be improved to diversify recommendations? It's quite evident that such systems have a popularity bias. Do you have any thoughts on that?
Can you repeat the first half of this? Sorry, I didn't get that.
Okay, the question is, can you comment on how group fairness can be improved to diversify recommendations? It's quite evident that such systems have a popularity bias, that is favoring popular items / post and marginalizing other niche but relevant items.
Not sure I have a good answer to that question. I wasn't so much on the technical side of designing the group
because I think the
fairness
way
algorithm. So
this relates to that equitable outcomes you talked about and how fairness should be.
yeah.
Some may talk about individual versus group, and I think it's more related. There's always room to improve and to diversify this recommendation to look at all these bias and other characteristics. But
yeah, I think one thing to sort of address these problems is, and this we haven't further studied this, unfortunately, but I think the user experience needs to make the consequences of these numbers visible, right? Probably with very concrete examples, because people start really realizing what the numbers mean once you include that into the UI. I think from an algorithmic perspective, what we used is equalized odds for this group fairness algorithm that was used in this experiment, but I couldn't comment on how you can improve the algorithm here. I wasn't the one who leveraged it. I think it was a standard group fairness algorithm that was used, not from us.
In one of your study, you mentioned the sample size n equals 24. Is that partly the ML practitioners are actually within IBM, or is it actually, in general elsewhere?
No, this is just a sample we took within IBM. There's many more practitioners in IBM than 24. Yeah, we have a large community of machine learning practitioners and data scientists in our consulting practices, and then we often work also with the people who are out in the field and use machine learning with customers, and they're part of the subjects of subject we study. But we stop there, right? Once we have sufficient number of participants for an experiment, then we don't sample anymore. We sometimes oversample, and we see that we have a good demographics, right? And it's kind of balanced or so, yeah.
The next is, thank you for the wonderful presentation. The code writing chatbot was really interesting. My question is a bit on the development side. What is the last function used when training LLMs? Any comments on that?
So we did not train an LLM for the chatbot here. This was actually merely done through prompt engineering, right? Using Codex. So we used Codex off the shelf. We did very smart prompt engineering, in which we always preserved the previous chat history and fed it back into the prompt. This of course has limitations, right, with the context size, but there wasn't a loss function involved in training there. Well, you could consider this training in a way, but it's not classical training.
Okay. Let's see what else I can see here. Okay, human AI collaboration is progressive. From one side of the coin, it's very valuable to make human lives better in terms of productivity, efficiency, and other things. But what about skilled labor empowerment when it comes down to traditional job market requirements? What are your thoughts on AI and job market competency?
Ooh, that's a very complex question.
I think it's kind of a very, I don't know, generic.
I think there is a tremendous opportunity for educational companies. And actually, I think it's also a huge market opportunity for leveraging large language models for training, skills, and education. And there's probably these very progressive companies, right? If you think about Duolingo, that now also moves into areas to train other skills other than language, for example, math, right? There's Khan Academy. And there's on the other extreme, there's our traditional publishers, right, that who are still trying to sort of get into the field of leveraging large language models for education. But I think the potential is actually immense. And I think that is one aspect where I see that AI will have an absolutely positive effect on the labor market, right? Where AI may cause shifts at the labor market is also probably a real assessment, right? How these shifts happen, how fast they happen, right? That is a different story. I sometimes have a feeling there is too much hype about automation, with too many immediate implications on the labor market, because in practice, bringing AI systems into companies to increase productivity isn't a trivial task, right? So I think there's a little bit of an overreaction to productivity gains with regards to the labor market at the moment, if you ask me personally, because the reality is somewhere else.
Yeah, you
we
talked
still
about
need a lot
this.
of humans actually, and we need to teach. So
Thank you. And you did talk about this over-reliance and under-reliance of this AI users, but I think, do you see any opportunities on this misuse of whatever the generative AI designs produce? If so, how should one identify misuse, or, or any comment on how we are going to deal with this designs that are going to be, partially going to rely on generative AI when we talk about people and computers in tandem working together to attack this human-computer AI design. I was just curious to see, I think there is opportunity for misuse, but I just want to hear from you to see what's your comment on.
yeah, I think there's tons of opportunities for misuse, right? There's all the disinformation that can be spread with large language models and evil use of those models. So there's prompt injection attacks, security, right? This probably applies very much to the speaker series. Unfortunately, this is not an active area of my personal research. I think it's extremely important. IBM Research does a lot of research in that space. Actually, I should probably connect you to some of our researchers there if you're looking for other speakers in the speaker series.
Please do. Please provide me some names. I was about to
But
ask
maybe,
you.
maybe what I should say, I think, is really important to what I talked about today when it comes to misuse, is that, and this is like, we need to grow into this as we develop machine learning systems, right? There is a machine learning development lifecycle. And risk and harms, right? They need to be front and center in the machine learning lifecycle, right? Today, they're often a secondary thought, because when people develop these systems, they first think about, oh, how do I create a system that makes me more productive in X and in Y, right? How can I solve this problem? But I think it actually begins already before you start thinking about this, right? You need to think about your use case, how it's going to be used, by whom it's going to be used. You need to actually do a risk assessment from the get-go, right? And then along the path, as you go through the machine learning development cycle, right, you need to really figure out, right, as you develop your prompt, as your model, you need to test, right? You need to be aware of potential risks and misuse, right? As much as you can, right? It will never be probably completely preventable, right? But I think you need to develop these systems with this in mind, right? And this happens often too late, right? It happens often too late when these accidents already happen, right? So that would be my advice to that question and my answer to that question.
Yeah, the reason why I asked that, cybersecurity is also always after the thought process of the design, right? So I think there is always this all combinations of misuse may happen and exploit.
And we are getting there, right? I mean, companies are aware of this. We have ethics boards, right? We have people who take this very seriously, and they inject people often in product teams that actually particularly think about the harms and risks that generative AI can cause, right? And and there's also software being developed also in our house, right, for governance of AI systems and how we can make them safe. So some of this can also be, automated, actually, right? Not fully, but there's also potential there. Yeah.
Good. Thank you. We're almost overboard on time, but thank you so much for your presentation today. You will receive a nice plaque from UND and a nice certificate from our dean. And thank you so much for taking the time to do this webinar, and hope you can visit our university at some point. Maybe we'll be in touch to and some interactions in the future.
Thank you very much. I would love that. And it was a
Yeah.
pleasure speaking with you.
Thank you, Dr. Geyer.
Thank you. Bye-bye.